Hello and welcome to Physics with Amol sir. So this video is for class 10th and we are going to continue with a chapter of human eye and the colorful world. In the previous class we saw the concept of atmospheric refraction and we saw how it affects the twinkling of the stars. Also we saw the concept of advanced sunrise and delayed sunset. Okay. Next we are going to move to the topic of scattering of light. Okay. So let's begin. Okay. So what is scattering of light? Whenever light passes through a medium and if there are some colloidal, that is suspended particles in that medium, what will happen is that light is going to strike these particles and it will get reflected in all the directions. Okay, this helps us to see the direction of light. For example, if you look on the ground, we are not able to see the rays of light. Is that correct? We know light travels in a straight line, but even if we see outside or we turn on a tube light, we are not able to see the rays. But if light is coming through our window and if there are some dust particles there, we are actually able to see the rays of light, right? This is the image that you must have seen in your house many times. So this image that you are seeing, this is nothing but the scattering of light. Okay, what is happening is light is hitting all these small particles, right? And then it is getting reflected. So when we see that reflected light, we are actually able to spot the direction of light, the path of light. So this effect is the scattering of light. This is also used whenever we are having some kind of parties you would have seen, okay, or there are some night shows. So in the night shows, what they would do, they have these laser beams, and for us to be able to see the laser beams, they will send a smoke around that area. So smoke is basically small particles. So when light hits that small particles, we are actually able to see that beam of light. Okay, so this is how we are actually able to use the phenomena of scattering. Okay, so this scattering of light due to the suspended particles, this is also called as the Kindle Effect. Okay, now when what we are seeing in our window, for example, okay, this is a very simple example of scattering. If the particles are much larger in size, what happens is the white light gets scattered. But something interesting happens when the particles are extremely small. So when the particles are very small, they can actually scatter individual wavelengths of light. For example, if the particles are of the size of around 400 nanometers, okay, very small, they can actually scatter the violet or the blue light. Okay, and if they are a little bit larger in size, let us say somewhere around 600 to 700 nanometers, they are able to scatter the red color of light. And it is this scattering which actually enables us to see the sky as blue. Okay, I am sure you must have wondered that when we look outside, the color of the sky appears blue in color. Now actually there is nothing over there. Okay, it is simply space. We have the earth, then around the earth there is a layer of atmosphere, and then there is space. As such, there is no physical quantity over there, that is the sky. But we whenever we see up in the daytime, we see the blue color. So the blue color of the sky is actually due to scattering of light. What happens is, around our earth we have the layer of atmosphere. This atmosphere, as we have previously talked about, it contains a large number of particles. There are some dust particles, there are some ions. Okay, they are very tiny. There are some even ice particles are there. Very small particles are there in our atmosphere. These particles are able to scatter the light. So what happens is, whenever this is our earth and this is the layer of atmosphere, when white light will enter our atmosphere, due to these small particles, okay, the particles are very small in size, around 400 nanometers. So what they will do, they will scatter the violet, indigo blue, that color light they are able to scatter. So the blue color light gets scattered because, as you have seen, it has very small wavelength. Correct. The red color has got larger wavelength, so red color is not getting scattered. Red color is able to move without any scattering. So the blue color light gets scattered, right? So many rays are coming. Okay, and when we look, the scattered light that reaches our eyes, and that is why the sky appears bluish in color. Okay, so this is the question that is asked in the exam. Explain why the color of the sky is blue. Okay, so remember, the sky appears blue because of the scattering effect or the Kindle effect. Okay, the particles in the air, they are very small in size, hence they scatter the blue color, and that is why we are able to see the sky as blue. Now of course you will ask, the smallest wavelength is actually for violet. So we should actually see the sky as violet. But why it doesn't look violet and why it looks blue? Simple reason, our eyes, they are more sensitive to the blue color. That is our retina. Okay, it is more sensitive to the blue color, hence it appears blue for us. Okay, so that is the reason for why the sky appears blue. Of course, the sky doesn't always look blue. If you see, look at the sky in the daytime, during the sunrise or during sunset, that time the sky looks reddish in color. That is also due to the scattering of light. Okay, so again, this is our earth, right? There is the atmosphere around our earth. Now, during sunrise, what is happening? The sun is actually on the horizon, right? So when the sun is near that horizon, that is when we are able to see the sunrise taking place. So at this time, what happens is the light that is coming from the sun, okay, we notice that because of these particles, the blue color light that will get scattered away, right? Which is remaining, the red color light is actually able to reach us. Why red color light reaches? Because red color, it has got the largest wavelength. Hence, to scatter red color light, larger particles are required which are not there present. So, the scattering of red light is minimum. So, light from the sun, when it reaches us, it mostly consists of the red red part of the spectrum. So, that is why during sunrise and during sunset also same phenomena is taking place. The sun and the sky around it looks reddish in color. Okay, so that is the explanation for why the sun and the sky appear reddish during sunrise and during sunset. So both these questions you should understand properly, why the sky appears blue and why the sun appears reddish during the sunrise and sunset. Okay, so with that, the theory part for this chapter of Human Eye and Colourful World is completed. What is remaining now are the numericals. So we will have a Google Meet class. There we will discuss the important numericals for this chapter. By that time, make sure that you have written all the question answers. I have already told you which are the specific questions that may be asked on this chapter. Make sure you have gone through all of them and make sure you understand each and every one. Okay, and there are some solved numericals also given in the textbook. Try to solve them. In the next Google Meet class, we will discuss all the numericals for this. Okay, thank you.